What's up? What's up? Welcome back. Today we're working on my terminal emulator. His name is Termi. We've been working on him for around a month now. And let's see if we can run him. Cargo run. So here he is. He's a little terminal emulator. He's somewhat functional, right? If I go like git log, let's kind of bring this text size down a little bit and try this again. Git log, right? We have like something here that's like somewhat reasonable. We're like scrolling through. We have colors, like resize. What else do we have? No, that's it. We're doing like some parsing of input, putting it as output, and he like kind of works. We've done a lot of work to like support a bunch of terminal features that make stuff like this like line wrapping work. There's actually like a lot that goes on there. But like kind of like the whole, what we have right now is like we've spent a lot of time basically we take input from our whatever application is running in the terminal. He sends us some characters. We process those characters to do things like, hey, could you move the cursor over here and then write some text over here? Basically it. And then he was like, could you make it bold? Can you like pad some lines? There's a bunch of like actions that terminals can request of their, or sorry, that shells and programs can request of their terminal emulators. And we're slowly like working through those things. And what we're working on today is we found that we have to rewrite the underlying storage model. And the question is, why? Let's find a bug. We'll show you the bug, and that will like maybe explain a little bit. So I type git log here. This looks reasonable. Maybe I'll, can I like reduce the font size a little bit so that it's a little bit less obnoxious? There we go. That looks somewhat reasonable. That is like a git log. Now when I resize the window, in some cases what ends up happening is the bottom of the window does not line up with where it should be, right? If I, maybe I'll do it in another window. Hold on. Console. Let's open up this guy. And we'll make the font a little bigger. And if I type git log in here, no matter how I resize this, the bottom of the page is always, like the cursor is always sitting at the bottom of the window. In our terminal emulator, that's not happening. And the question is, why? We like debugged this last stream, and we found that it's a problem with how we store the data. So the way that we have it set up is we kind of store like the entire output from the terminal in like one long string, right? So they have like, they type like ASDF and that gets stored here. They press enter, we put in a new line, and they type like 1, 2, 3, 4. That gets like stuck in this like 2D buffer as ASDF, and then we show it as like 1, 2, 3, 4 here. Now, what happens if they put in a lot of text, they put in a lot of stuff here, and it like automatically wraps, right? No new lines, it just like automatically figures that out. Because like it hits the width and it goes like, oh, time to keep putting characters on the next line, I guess. And if they put in lots and lots and lots of data, what ends up happening is they keep writing data, and we say, well, our terminal width or our terminal height is like a certain size, so let's just say that we'll like move it down so that like what fits is down here now, right? So we haven't actually like changed like the data at all. We've just inserted more, and by like trying to figure out how many lines we can show, this stuff gets like effectively evicted into scroll back. Now where this gets a little confusing and a little tricky is applications can like request to write in any point in this 2D area, right? So we say, hey, application, I am like 10 characters by 20 characters tall, or sorry, 10 characters wide by 20 characters tall. And so they can go like, hey, can I go right here? And I just want to like put in some text ASDF in like the middle of the buffer. And we go, well, okay, well, our backing data is like a string. So how do we get here? Well, if we wrote ASDF here at the beginning of our buffer, that would show up in the top left. So that's a no-go. But we could say, hold on, how do I get back here? We could say, well, what if we put like a new line here, and a bunch of spaces here? So you like new line, space, 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 ASDF. So far, so good. And this is like what this has worked up until this point. Then they say like, I want to keep writing, right? They want to say like 1, 2, and like wrap it down here 3, 4. So that comes in as like 1, 2, 3, 4 in our buffer. No problems yet. Where it gets kind of tricky is what if they want to go back to this point, like maybe back to here, right? And they want to write like X, Y, Z, W. Now, an important thing to notice here is that they did not request a new line. Okay, they expect, what the terminal application expects is that this will like wrap like this, and that's it. But what we do is we go in here and we say, okay, let's put in like X, Y, Z, W in this area between the two new lines. But we don't overwrite this new line because like we don't know if this new line is here because somebody pressed the enter key on their keyboard, i.e. like there's like actually semantically supposed to be a new line there, or if because we put it there for padding purposes. And so what ends up happening is we end up with, instead of XYZW being written in the buffer like this, he ends up being written kind of like this. So this stuff all comes up, and it ends up looking like XYZW \n, which like puts a whole new line in this segment, which means that the scrollback gets triggered and the top of this stuff all goes away and gets like put into scrollback. And so now the application expected that it's going to see XYZW on screen, but what actually happens is that the XY goes away. And so this like model of storing data this way as like one long string is now like clearly not, well, maybe it could work if we did some tricky stuff here, but it's like starting to reveal itself as like the wrong model. Clearly like applications expect to work in this like more 2D space. And we need to semantically track whether or not a new line is like supposed to be there or if we're wrapping for some other reason. And we need to support going to arbitrary spots in this buffer without injecting extra new lines, because then we like lose information. Okay, that's the background. So we need to rewrite the entire storage layer, right? How we're storing the data. And so we kind of like experimented with this yesterday, and we were like struggling. What we tried yesterday was we tried like just pre-allocating a box like this and kind of filling it with zeros everywhere there wasn't text. Then when we write text, we like overwrite the zeros with something else. But it kind of gets like a little bit hairy and confusing doing it that way. There was just like a lot of like struggles with like data manipulation. And so I was like thinking about it last night, and I'm like, well, what do we really want? And I think what I found was the abstraction of a line of data is quite important, right? We kind of work on lines sometimes. Sometimes we kind of want to work on this buffer as like one contiguous thing, right? If they write like 1, 2, 3, 4, 5, it would be kind of nice for that to just like resolve into like a mem copy, right? Just take the bytes and stick them in there. But sometimes it's important to think of things as like a line, right? Because like, you know, if we keep writing down here, blah, 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 we need to like take, every time we hit a new line, we have to like evict one because like we have like a certain height of the screen that's allowed. And what I kind of ended up deciding is that it makes sense to have something along the lines of, let's see, set file type is Rust. What would be kind of nice is if we could have something along the lines of a line abstraction. So we could have a line, right? And he could have like a vector of U8s inside. Hey, Ron Dev, thanks for the raid. Appreciate it. So you have a line, right? And since this guy's a vector, these guys can now be like arbitrarily sized and stuff. So you can start having your buffer abstraction look like, okay, so they wrote like ASDF here, and that's a short line. And then they have like 1, 2, 3, 4, 5, 6, 7, 8, right? That's like a longer line, whatever, right? We can have like line by line, and then our like buffer can be something along the lines of struct buff. And he can have like lines, and he's going to have a bunch of lines, right? Great. So far, so good. But you look at this, and, you know, the like low-level dev in my brain goes, vector of vectors, that's no good. We don't like vectors of vectors, because like each of these lines is going to be like in a different spot in memory. You know, it's kind of nicer if the buffers all kind of packed together so that like the compiler can do things like, you know, like this optimization of if we wanted to mem copy from here to here, we want to like keep that ability. Okay? Sure. So now our line abstraction becomes kind of a little hairier. We can't have like a vector here, but like this like resizing ability of lines does still feel kind of nice. So what we might want is like some abstraction that's like, okay, our buffer is like a vector U8, and he is like width by height long. Sure. And now externally, we can like maybe track the lengths of each line is like vec u sizes, right? So this basically says these lengths are going to be, we're going to have height lengths, and for each line, we'll track the size, and we'll just like let garbage kind of be in this area here, right? Anything that's like not filled in yet is just going to be filled with trash, and that's okay. And then when we like extract the data from this thing, we'll just like keep those lengths, and we'll take them into account. And so now, we still want our line abstraction though. So maybe we can make a line abstraction that like, references the data of a certain line in the buffer, right? So he can say like he's got a mutable U8 slice, and then he can say like length is going to be a mutable reference to the length. And then you could do something like in this like buffer abstraction, you could do something like get line for self, right? And like line usize. And he can return like some line. And we construct this guy by taking like the buffer is going to be our buffer, but segmented at like line times width to line times width plus width or something, right? And then we like take the length as a self length line, right? Something like this. And then it like kind of starts to work out. But then here's where, first of all, there is an extra piece here where we also have to track in our lines, we need the new lines associated here as well. So this guy needs to have like, whether or not somebody typed a new line for this line, we keep that guy in here as well. It's starting to get like kind of complicated. This is also height long. But then here's where we're going to get a little crazy, I think, today. You look at this and you say, okay, first of all, this is not worth doing at all. I would like to make that very clear. Not worth it. But I think it would be fun if we're going to make the argument that like it's nice to have one contiguous buffer. You could also kind of make the argument that like the lengths and the new lines should be stored in memory close by as well. That just kind of like makes things nicer for the CPU. He can just load the whole buffer into the cache, and then he can work on the things together, blah, blah, blah. And so what would be kind of nice if you could have something of that's kind of like struct buff, and he has, the size, maybe like n, which is maybe we'll call it width and height. And then you could have something like buff is, an array of U8s of width times height. And the lengths of like each segment for each line are going to be stored as U size of height. And the new lines are going to be stored as like bools of height. And that's kind of nice because now these are all stored next to each other, cache friendliness, whatever. But this doesn't fucking work because these are compile time parameters, and somebody's going to be resizing this window, and so we don't really have like this information of what the width and height of the buffer at compile time. Kind of. You could like maybe set like a maximum size here and then like subslice it, but it would be kind of cool and fun if we allowed dynamic allocation of this. And so that's kind of what I want to try today, is see if we can create a buffer that dynamically allocates something like this. Okay. So, but like, yeah, still keeping this line abstraction, still keeping this buffer abstraction. And so I think that this is like probably going to end up being like kind of complex, overly complex, not worth it. Just clarifying, not worth it. Wouldn't do this in production, but it's fun. And I think it's like it would be kind of like a fun tool to have in the belt to be able to do something like this. And so I think we're going to like prototype this like abstraction, outside of the Termi project, because I think that that'll make it easier to work with. And if we get to the point where that like abstraction is working like okay, then we can try integrating it. But I do just want to like experiment with the idea as a whole. All right. So that's where we're at. I guess let's kind of start with this guy in like some sort of test project. What's in here? Nothing interesting. Okay, sure. So let's say that we will save this guy as test source main. We want to overwrite this, and then let's go into that test directory. Okay. Now let's get rid of this window, get rid of this window. And we need to... Oh, shit, I want it to be in the termy development context. One sec. Okay. So, test, go over to main, cool. So, we have to keep in mind that this isn't possible, but it's pretty close to what we want. And so I think, I was like Googling last night, like, what is an okay way to do this? And nobody, I don't know, maybe like I couldn't like Google effectively, but I couldn't find anybody who was like trying to do this, probably because, again, who would want to? There's no fucking point. But I want, like, nobody was doing it. But I was like thinking about it, and I think what you could do, hear me out, is you could allocate a chunk of bytes, and you could cast those chunks of bytes to arrays of usizes and bools. I've seen this like pattern before in like C++, like utility libraries, where they like they make a thing that's like it's actually under the hood, like struct thing. They have like it's actually under the hood, you know, a vector of U8 or something. But then when they like try to access it, they say like they say like thing as other thing, right? And they just like take the thing and they like just cast it basically. So they say like this thing is this other thing, and they just say like data as pointer as other thing, right? Like what's the Rust syntax for this? Something like this. And so I wanted to see if you could use that concept here. I wanted to try it. And so what I am thinking is we take our buffer. First of all, I don't want him to be a vector because that's scary. Vectors can be resized, they can reallocate, blah, blah, blah. So I think I kind of want it to be like a boxed slice, like this. And he is going to hold all of the information to get out lengths, new lines, and actual storage. What are you using for your .file management? I've seen your GitHub repo, but it files are encrypted or something. Oh, I forgot about that. I haven't used that in a long time. But I mean, the concept is still the same. I use a like Git work tree in my root repo, or sorry, in like my home folder. But I don't share those online because I don't think that it's really safe for me to put my .files on the internet. I don't know what's in there. I'd rather not like worry about it, right? There might be like keys for things in them or whatever, so I just don't share them. But that GitHub repo was using something called what's it called? There's some form of like Git extension that lets you GPG sign your whole repo, or GPG encrypt your whole repo and push it as this like blob of shit. And so I've always worried that like maybe GitHub will like, get mad at me for doing that at some point. So I haven't done that for a while, but that's what those blobs were. Okay. So let's say that we want to allocate a buffer of width, usize, and height, usize. And then we can say let buff is buff new 10 by 10. And so we need to allocate something in here that is total size is going to be something like width times height. I'll call this data size is width times height. Length size is width times, no, just height right? The number of lines, we want to store one length for each line. And we want this to be times the size of a usize, because we want to store them as usizes. And then we have the same thing for new line size is height times this, but it's the size of a bool now. And you could do something like, now you just say vec, what is it? I want to like allocate a vector full of zeros with data size plus length size plus new line size. And we can like convert this into a block. We say let buff is equal to this. And we return buff, right? And then say, so now what do we do with this? Say we wanted to like get the lengths out of this thing. So we say like function data, or maybe we say like function lengths. We could like extract this guy as, you know, some sort of like chunks of usize. And we could say like, hold on, let's say we store data size as a usize, length size as a usize, and new line size as a new line. Okay, simple. Data size, length size, new line size. And now here's where the like bullshit happens. The bullshit would be that you take your buffer and you say, can we go from like data size to data size plus length size? And could we get that? This is going to be like some sort of U8 slice. But we wanted like U sizes. So we could do something like as pointer and then like cast this to like const U size. And then like create a slice out of this in some way, right? Like let usize pointer is equal to this, and you say like stood slice from raw parts usize pointer and like new line size minus length size. Like you need like the number of elements here. But an important thing to think about here is that you can't just like take an arbitrary spot in like a buffer of U8s and turn it into a bunch of U sizes, because like the alignment might be wrong, right? Like the way like these like slices work is you have like a pointer to a thing and you like dereference the pointer, but like the CPU might have like some restriction that's like, okay, if you're working with integers, you can only store integers at multiples of like addresses that are multiples of 4, because like I don't really know why, but it's just like a thing that they do. I think it's because like the load and store instructions like work on those specific boundaries or something. So this starts getting like really complicated. You can't just like allocate a buffer that's the size of these things added up. You actually need to like make sure that the thing is like aligned correctly. And you don't really know where like the vector is gonna like allocate this buffer to. And so you actually have to like be careful about that alignment too. And so I think what you can do, I think what we can do is we could allocate a pointer aligned to U sizes. Then calculate size of data. Pad data so lengths are also aligned. Calculate the lengths. Calculate size of lengths. And then pad again so new lines are aligned. I think. This is all kind of like fuzzy in my head, but I think that this would work. I think. And so you could do something along the lines of, let's see. So total, we start with the data size. That still makes sense. But now this like, maybe we store this as like length offset is equal to usize aligned offset, starting with the data size, right? So this is like, we have data up to this point, and then just like increment this until it's aligned to the correct thing. And then we say let new line offset is bool aligned offset of data size, length offset plus stood size of a usize times the height. Maybe. I don't know. We'll fucking see. Okay, and then let total size is the new line offset plus the number of bools we're trying to store, size of bool times height. And then we need like an aligned vector from this stuff. So I think you can do like, we can like manually request an allocation, I think. Stood alloc. So you can like allocate a thing with a specific layout where the layout has size and align. Yep, so you can do use stood alloc self and layout. And we can say like let layout is equal to layout from size align. We have total size and the alignment of a usize. So we can say like the usize alignment is something like a line of usize. Yep. And the bool alignment is alignment of bool, and the U8 alignment is the U alignment of a U8. And so I think in this scenario, we can align to like the common multiple of the three. And I think that the usize alignment should always be a multiple of the bool and U8 ones, I think. But we can check. So we can say usize alignment percent bool alignment. We just want to make sure this is always 0. And same with the U8 alignment. So make sure that there's like, these guys are divisible. And then we can say that we want the alignment to be relative to usize alignment. Okay. Then we can allocate. Right, we can say let alloc layout. Maybe this layout needs to be unwrapped here. Is that right? Yeah. So we have like a pointer. And then we can say that we want to convert that pointer into a slice. Because Rust has like thin pointers and fat pointers. So we can't just like use this guy. You can't do like, this guy is a mute U8. And you can't do like, let slice, which is a reference to mutable U8. You can't do like pointer as mute U8. Like that's not legal. Sorry, a U8 slice. You can't do that because Rust has like fat pointers. So like normally you have like just a number 0x1 2 3 4, right? And you like say this is like a memory address that points to some like thing in memory, boom boom boom, and this is like, this just points to like a number 4, right? And so if you're like, I have an integer at like this location, I can just dereference this. But Rust does this like fat pointer thing where their pointer is not just like the address, but they store like 0x1 2 3 4 where the thing is, but also like the size of the thing if it's pointing to like an array. So if you have like something like this, you have to do something like stood slice from raw parts mute take the pointer and the total size. And then you have like slice is a mute u8 like this. And then if we want to use this guy, we want him to like automatically deallocate himself. I think that you can do something like box from raw of slice as mute pointer. And then I think that you have like buff is a boxed slice that will automatically deallocate. I think. I'm not entirely sure here, but I think. He doesn't like something in here. Expected star mute blah 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 blah. Okay, so first of all, let's make sure that everything else it compiles here. So we'll say usize aligned offset from data size, which is a usize is going to be unimplemented for now, and bool aligned offset is also unimplemented. These need to be usizes like this. Cannot find, this doesn't work. So maybe we'll write unimplemented here. And what is he complaining about here? Slice as mute pointer. Expected star mute u8 found star mute u8. What is he complaining about? Slice? That's fine. Oh, do I need to like dereference the slice so that we get the as mute pointer of the thing instead? No? I'm pretty sure this was supposed to work. Box from raw. Do I just do like, oh, maybe I do slice as mute u8 like this. There we go. That's what I'm looking for. So I think now I should be able to return buff, and then just store the offsets. And maybe we store like length offset as a usize, new line offset as a usize, and we probably want to store like the width and the height as well. I think. We'll see. I'm pretty sure that all of these are going to be necessary. Okay. So here's where we can start getting crazy. We can do something like, let's try to get like the, well, we'll split up all of the things that we care about. So we know that we wanted buffers, lengths, and new lines. So we can take data and get take mute self, and he's gonna return our 2D array as, I wonder if for now we'll do him as like contiguous. That's fine. One slice of u8. So here you can just say self buff, to self width times self dot height. That's where the data should live. Now here's where it gets a little tricky. If we want to do like lengths, he's going to return a bunch of usizes, and we can say self buff from new line offset to the new line offset plus the size of a usize. Oof. Yeah, I think like this times the height. So this is how many elements we expect to have. So this is data, which is a u8 slice like this, I think. And I don't think that you can do like std mem trans mute data. I don't think this is allowed, but maybe it is. It might be. What's it complaining about here? This needs to be an ampersand. Maybe that's fine. And then we just do the same thing for new lines. Oops. I used the wrong thing here. This is new lines. This would be length. And new lines here should be bools. Bools, bools, bools. And I guess we want like mutable versions of these guys so that we can modify them and try doing some shit. So this guy is mute. This should be mute, mute, mutable, mutable. And so it'd be interesting to see now. Say I like look at the buffer and I get its data and I just try to fill it with spaces. Well, maybe, okay, let's start by saying, what are these things? So like buff.data, let's see first, like, are there lengths right? So we can buff data lengths len and new lines length. So this should be this should be 5 by 10, so we should have a 50 size buffer, 10 lengths, and 10 new lines. So if we try to run this, it's so funny, it's not my project, but I can't wait for the day you run an nvim and turn me. Yeah, dude, that's gonna be sick. For sure. I also am excited about that. So this is unimplemented. I can never remember, there's like some formula for like calculating alignment. It's something like some weird masking shit. Yeah, operand plus alignment -1 and negated alignment -1. So I guess that's like, say your like U sizes have to be aligned at like 8-byte boundaries. They're saying that you do alignment -1 is 7, which is a bit mask of all ones. So they're saying operand plus this, so you have like data size plus 7 and 10000, right? Which I guess means that like, I think that's right. Because this is basically saying like, if your alignment is 8, you can add 7 so that it will always be like, pushed into like the next increment, and then you mask out the bits that don't matter. Yeah, I think that's right. So you can say align to size, and this is gonna be like val is a U size, and his alignment is also gonna be U size, and then it's let mask is equal to alignment -1 val plus mask and the negated version of mask. And so this can be U size aligned offset is going to be val. We can say align to size val stood mem align of U size. Nice. And this is a line of bool. I think that's right. So we got data length was 50. Then our length was 80 and 10. So these are wrong. Which makes me think that this transmute is just like totally illegal. Not allowed. So maybe we do something like, well, maybe we just got something else wrong. Maybe. I'm not sure about these transmutes, so they're in the top of my head. But I guess let's maybe log the pointers of each of these guys. Or like the offsets. So print line, we'll say like length offset is buff length offset. Let's just see what it is. 56. So 5 by 10. What's the U size alignment? U size alignment is stood mem align of U size. So U sizes are aligned at 8-byte boundaries. We have our data ends at 50, and so like the length offset is 56. So it looks like that alignment code is working correctly, right? Because 56 is the next increment of 8 above 50. So I think we're chilling there. And then I also wanted to make sure that the data in the buff pointer, like, where does it live? Because we need to make sure that that's aligned by 8 as well. So we can look at buff dot buff as pointer. So this is here, and is this 8-byte aligned? Python, you like do like this %8 print. I need to print it. Yeah, sick. Sick. Cool. Okay, so I think the lengths, I'm like not confident in this code here. So I think instead we do is we say data as pointer. Let's try this. Self buff as pointer. This is the start of our data. We cast this into a mute usize. No. We add length offset. Yes. And cast that to usize pointer. Yes. I'm pretty sure this is right. Well, maybe. I guess I could never be too sure, but I think this is right. So then we can like take this area of the buffer, and then we've now got a usize pointer, and we can say stood slice from raw parts mute lengths start and the height. Arguments is not correct because this would be as pointer as mute pointer. And this needs to be as mute usize. Okay. And now if we run this, length is 10 now instead of 80 like it was before. So I think this is correct. And so we just apply this same thing to the new lines section. So this is just going to be, instead of length offset, it's new line offset as bools. And this is new line start. I think. Okay, so now what we can do is we can try filling these things with data. Oh, okay, let's look at their pointers. So this is our data pointer, this is the length pointer, and this is the new line pointer. So this is buff lengths as pointer, new lines as pointer. And these are different values that are close together. So AA40, AA78, AAC8 looks probably right. And let's think about how can we like verify that these guys are correct. So we could say like buff data fill. We could just like fill it with like the letter A. We could take the lengths and fill it with like, I don't know, dead beef, and the new lines fill it with true. And then we could print the contents of each of these things and make sure that they are correct. So buff is going to be buff data, lengths, and new lines. So this is lengths, new lines. We want to print this as hex because we wrote it as hex. So that's looking promising, for sure. I guess it would be interesting. So we thought that the previous method of using transmute was wrong. So it'd be kind of interesting to try seeing if this test that we're using to check if it's right, fails if we do it the other way. The way we were doing before, that was giving unreasonable answers. So lengths. What did we do before again? It was something like we did let lengths is equal to self buff from length offset to length offset plus something. Self height times stood mem size of usize. something like that, and then we did std mem transmute lengths. With a little and mute here. Okay, so that segfaults, which is good. That means that like the test is somewhat reasonable, and we could probably even do like something like run it in Valgrind. And Valgrind should tell us, hey, you're doing invalid memory accesses, I think. Which is a good way to double check that everything's okay here. Yeah, so invalid write, killed, etc. Looking chill, looking chill. So let's go back to this way and run it in Valgrind. Cargo builds, run in Valgrind. And 0 errors. And what's nice here is I was also a little bit unsure about this, like, if this box U8 would do the right thing. With like automatically freeing this like slice that we made, but it looks like it is because Valgrind's saying that there's no leaks, which is nice. So that's kind of cool. We've kind of like made a dynamic version of this that seems to work. I guess what we also want to make sure is like to make sure that there's no overlap. Is maybe we'll do something like this. So we'll do this. We'll change all of the data again and make sure that if we like, you know, modify it in like a different order and change all their values, that we see consistency there. So we see like 97s, dead beef, false. Then we see 98s, beef dead, true. So I think it's working. I think. Which is kind of fun. That's not actually as hard as I thought it was going to be. Which is pretty cool as well. Pretty cool. Happy with that. Okay. So we have our buffer abstraction, which we actually want to call it terminal buffer. And now we want to say like, let's make like our line abstraction out of this. So we know that our lines, we wanted them to be like vector-esque, except like in that they can have like expanding sizes, except that they're backed by like a fixed size thing. So you could do something like input line function new, and he's going to take in a buffer. This can be anything here. This guy probably needs, he's going to take in a mutable U8 slice. He's going to take in a length, which is a reference to a usize, as well as a new line, which is a reference to a bool. He's going to return a line with lifetimes elided. Elided. There's a lifetime elided. Okay, and then we just return the line. Buff, len, new line. He says that he needs a lifetime parameter because all of these guys have to be bound together. Sure, there's no obvious way for the compiler to know that. I guess he should be able to figure it out, but whatever. We'll help him out. Okay. And what are we going to be doing with these lines? Well, in the usage of like the terminal emulator, we are going to try to write a large chunk of data maybe to a position in the line. I guess, well, what is the buffer going to be doing? Like at like the terminal buffer level, we're going to be trying to like insert data at some position. So we're going to have like data that we're trying to insert, and we're going to be trying to insert it like some like X position and Y position. Okay. And he's going to be doing something like let's think. We're gonna want to like extract a line here. Maybe not. Yeah, we are. We are gonna want to extract a line here. I think. And his buff is going to be... Inserting data. So he's going to go line by line. On the first line, this was an edge case we saw yesterday. Start pushing data at some offset. For all other lines, push from beginning. Maybe we start with the line abstraction. That'll make this like clearer. So we know that if we have like a lot of data, more than can fit in a line. Maybe what makes sense is that the line, you like try to insert some data into the line, and it will tell us how much of the data it consumed. That seems reasonable. So we can say like we have a reference to ourselves, and we have some data that we're trying to insert at some position. And he's going to say, hey, this is how much of the data I used. Okay. And so we're going to look at the capacity of the, the capacity of the line. Well, I guess, let's think. Yeah, I think we do need to store the capacity here. I think. And I think that the capacity of the line is just the width of the buffer. Okay. And so we're going to say like max copy length. Yup. Is the capacity minus the position that they're trying to copy from. Copy length. And then we also have to make sure that we take the smaller one of that and actually how much data is in the buffer that they're trying to copy from. Okay. Then we return how much we copied. And we say the buffer from pause to pause plus copy len. Yup. Is copy from slice data copy len. So far, so good. Is there like, we're not going out of bounds of anybody, right? No. Oh, I guess we don't store the capacity. We don't need to do that because the capacity is the buffer length. We don't need that. We don't need that. So this is self buff len here like this. Okay. And we need to adjust our length here to be the minimum of the existing length or pause plus copy len. So if they overwrote data, then the length doesn't change. But if they do overwrite data, then this like will be bigger. And I guess this needs to be dereferenced. But we need to look for new lines, right? We now know that like new lines aren't part of the data anymore. They're being stored outside. So it's going to be something like new line is equal to we'll call this like clamped data. Let's think of this. Okay, so the data might be something like 1, 2, 3, 4, 5 new line. and say that they are inserting at position 0 and it's width 5. So our copy length here will be 5. But we need to check if the thing after the copy length is a new line. So we want to do something like self data. Well, maybe we just do like data position. Data up to the copy length plus 1. Find out if there's a new line. Like this. But this is yeah. Maybe we say find. And then this is a little sketchy too, because the copy length might be too far. So we'll say like let new line search length is the minimum of the copy length and copy length plus 1 and the data length. Yup. Okay, so we can say, hey, in the new line search length, length, we need a T in there, length. So if we find a new line, self new line is true. Okay. And we also have to say, we have to keep a track of this position, because if position is equal to copy length, then we need to say copy length plus 1 here. So maybe we do this down here. And we say copy length plus 1 is how much we consume here in this case. Oh, actually the copy length should be clamped to if we find a new line. Because we can't, within a line, we shouldn't be copying more than a new line. So the copy length is actually, again, the, fuck. This is tricky. Let's see, let copy length is equal to this. This is so tricky. 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 So we want like copy. For now, we'll just say we can search the whole buffer. Position. Ooh, wait, we can do. Yeah, we will. That's fine. So data iter position b is equal to new line. And here we'll just say fix me clamp to copy len. Actually, no, we can do it like this still. That's still fine. So data new line search length iter position blah blah blah. Okay. And what are we doing with this new line pause? If let sum pause equal to new line pause, copy length is now equal to the minimum of copy length and new line pause. Yep, because this might be one pass, right? This is 1, 2, 3, 4, 5 new line. Copy length is going to be 5 for the new line, and then the new line pause is going to be 6 because the new line's there. Because we added 1, and then we say sorry, like this. We adjust the copy length, and so this guy has to be mutable. Okay, and then down here, if let sum pause is equal to new line pause, then we need to say that we return the new line position as the amount we consumed, else we return the copy length. I think that's right. I think. Because if there's a new line, we consume up to the new line. And the new line can't be farther than the amount of data we're trying to copy. Yeah, I think that's right. I think that's right. And so now when we try to insert data into the buffer, we say it's going to be some loop where we iterate line by line. We're going to say let line is equal to line new. Data is going to be the buffer at y times self width to y times self dot width plus self dot width. Yep. And then we need like the length and the new lines. So these guys actually have to come from these like helper functions. So say let data is equal to self data, let lengths is equal to self lengths, and let new lines is equal to self new lines. Okay. And everything's good so far, right? Yep, okay. And then we can say let line is equal to line. Let data start is equal to self width times y. Let data end is equal to self y plus 1, y plus data start plus width. So then we get data from data start to data end. What order was this like line constructor in? Line new, buff len new line. So len is lengths y, and new line is new lines y. And I think these get to be mutable references, probably like this everywhere. Yeah. Oh, double mutable borrows. Okay, we can't do it this way. Hold on. So if we get the data out of this guy, and then we try to get the lengths out of this guy, Rust gets mad because it doesn't know. Like, both of these guys are trying to borrow self buff as mutably, which isn't like. So maybe we're going to try to do something like get them all at once. So we'll say, like, get myself as elms. Yeah. And he is going to return, like, terminal buffer elements, which is going to be tied to the lifetime of myself, I think. Because he's going to say struct terminal buffer elements is just going to be the data, which is going to be a mute u8, lengths, which is going to be usizes, and the new lines is going to be bools. And these guys all have to have lifetimes associated with them, which are all going to be the same. And so we're going to do something like self buff split at mute, split from the length offsets. We have let data and length the rest. And then we're going to say let lengths and new lines is going to equal self or data split at mute, the new lines offset minus the length offset, maybe? I think. And then we have to cast these guys into the right thing. So we can do, like, this thing again, where we say length start is the lengths as mute pointer, no addition here as star usize, And we do the same thing here for new lines. New lines, new lines, new lines. And then we just return terminal buffer elements with data lengths and new lines. Is that right? He needs us all in unsafe, sure. I don't give a shit. He doesn't like this because this guy expects spools. He got usize. What's the problem? Oh, because this is new line start. Oops. Okay, so let's now say that each of these guys uses this as elements thing, and then make sure that our tests from before still work. So as elements dot data lengths and new lines. Okay. And this shouldn't be data, this should be rest here. Oops. And then we just kind of kill this function temporarily and make sure that like this still works. So 97 dead beef false, 98 beef dead true. Lengths look good. And let's run our Valgrind check again. Everyone's happy. No, wait. Oh, rerun with -s. All blocks are free, no leaks, 0 bytes and 0 blocks, error summary, 0 errors. Yeah, I think we're chilling. I think we are chilling. Okay, so now here we're gonna say let lms is equal to self as lms, data is equal to lms data. I guess we can just use it like this. Right, so today on the menu is some nasty Rust. Gotcha. Yeah, absolutely nasty Rust. I agree. But it's fun. It's fun. That's the fun. Yeah, we're having fun. So this is going to be lms data here. And this is going to be lms lengths, lms new lines. And we have to cache the width and height because it's going to bitch about mutability problems. So if we just say like this, that solves that. Okay. And then we say line, insert data, data. And the position is X. And then after we insert the first line, X gets reset to 0, Y gets incremented by 1, and the data has to be adjusted to consume how much we consumed. So we say let data is equal to, we'll say let consumed is equal to this. Let data is equal to data from consumed onwards. X equals 0. This isn't let. This should just be reassignment. Y plus equals 1. Okay, wait. Well, this is starting to look maybe reasonable. Height isn't used. But it will be. So we can say if y is greater than or equal to height, fix me push into scroll back, but for now we'll just break because we're just trying to prove something right now. Then what? If data is empty, we also will return. We're done. We're done copying. And now we should be able to do something crazy. Like we should be able to say buff insert data at what, like hello world at 5.5. No, not 5.5. Yeah, 5.5 is fine because it's height 5, maybe width 2, so 2.5. And then we can maybe print line buff data. Cargo run. So we inserted hello world at 2.5 and we're printing it out and we have some stuff here. Oh, fuck. We're looking at unallocated data in here somewhere. Because when we allocated, we didn't zero it out. Maybe. I think. Which should be fine. What we should do is actually, we should maybe serialize this guy. into, let's just make him into a string for now. And what he's going to do is he's going to go in for y in 0 to the height of the buffer. He's going to push some stuff into the string. Okay. So here he's going to do this same data start, data end thing, which should almost certainly be factored out. But for now, we copy paste. I guess this guy can actually be outside the loop. He only needs to retrieve the elements once. Which means down here, he's also outside the loop. Okay, and then we say line serialize. And we'll say ret.extend this. And ret push a new line after, because we're, no matter what, at the end of a line, it's okay to have a new line. Even though the data model doesn't have to store the new lines, we can like put the new lines in the strings no matter what. I don't give a fuck. Probably. Maybe. I don't know. We'll see. And so then to serialize the line, serialize, we're going to take self, and we're going to return a string. Yup. And we're just going to return stood stir from UTF-8. Maybe this is going to return a stir with an elated lifetime. Awesome stream. I love how much you're getting done. Hey, thanks. Appreciate it. We struggled yesterday. You should have seen how slow we were moving yesterday. It was a disaster. It's crazy how, like, just, like, not thinking about stuff sometimes, like, makes it so much easier to implement it. Right? Like, I just, like, was, I was, like, struggling, walked away, played some video games, and then I was like, oh, I have the answer. I'm going to do this line abstraction. And then it's like, it seems like it's working fairly well so far. I guess we'll see, but it feels like it's working good. And it's like, I don't know, I think there's something about, like, 8-hour work days at work that I'm, like, pretty sure are, like, suboptimal by a long shot. Just because of, like, how often, like, I slam my head into the wall, come up with, like, the wrong thing, and then just walk away and come back with the right thing later. And, like, maybe slamming the head into the wall is, like, an important part of that discovery process. But I think, like, you get so much from taking a break, which is pretty interesting. Okay. So we're going to look at our buffer, and it's going to be limited to our current length. Did we adjust the length? We did. The time away helps the subconscious chew on the problem. Yeah, for sure. And for now, we'll just unwrap this, because I don't really care if it's wrong. And U8 cannot be indexed by this, because it needs to have a little star on him. And probably, I think this extend should be push stir. Arguments are incorrect, so this just needs to be a character, not a byte. This guy doesn't like borrowing self as mutable, so we'll just write mute here, even though it's, like, technically not needed. This should be height, not self. Okay. And now I think that if we serialize the string, we should see that hello world. Fuck. Fuck. We do not. Okay. Now the question is, why? Why not? Okay. So let's look at our loop of inserting data. So we can say consumed this much at line this. We can say consumed and y. Consumed 3 at line 5, consumed 5 at line 6, consumed 3 at line 7. So that looks like pretty promising. And then maybe can we, like, print line the line here? He doesn't have debug implemented, of course. Why would he? But let's take a look skis. So all of these guys, the lengths aren't being adjusted. I see. Because I always get this fucking min and max swapped. So this should be the maximum of these two. So we either want the existing length or how much we copied, and that should extend it. Hell yeah, baby. Look at that. Hello world. This is not aligned correctly because we have to pad. We probably forgot to pad the buffer here. So we need to do, when we copy data into the line, we have to say, if self length is less than the position that they're trying to insert into, then we need to, what is it, like, extend, there's like some sort of resize, right. Self buff. There's no resize though because it's a vector. It's not a vector, it's a slice. So we need to do self from buff, self buff from the position that it's currently filled to the position that we want to write to, needs to be filled with spaces. There we go. Okay, so hello world. And it looks like it's like wrapping. And maybe it would be kind of nice is if each line, maybe when we serialize, just for now, it would be nice for each line to say ret push a open brace and a close brace, just so we can kind of like see. I want it to be visual, you know? With a new line. Right, so the brace has to go here. There we go. Maybe also print the line number. Yeah, that's not crazy. So we can do like this. Push ret plus equals format this I think, and then we put in y. I think that's allowed. And then I put an ampersand here. Okay, that's reasonable. That looks right. Because we inserted at position 2 on line 5. And then let's see what happens if we like make the width higher. So at 1010. Okay, cool. And now let's see what happens if we put like a new line in before the O. Right? Like just like hello world. Bug. Bug. Because we got to the new line in hell, but then line 6 and 7 didn't happen. So the consume length here is maybe wrong. Where's our like main loop? Or not our main loop, our insertion loop. So this guy, he printed consumed 0, 0, 0, 0. So that's a problem. Probably because he's finding the new line pause. Probably. I would bet. Here, if we said print line, new line pause, he's probably writing 0 a bunch of times. Fuck off. Some 0, some 0, some 0, some 0. So we were just off by 1 when we, this should be like this, plus 1. There we go. Okay. So hello world is now getting split correctly. And we also want to see if we flagged the new lines correctly. So can we say buff new lines? We should see, oops. We should see one new line counted. False, 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 false. 1, 2, 3, 4, 0, 1, 2, 3, 4, 5. Yep. So we see one new line here, which is pretty good. And if we maybe shrink the width again, it's still wrapping it, and we only see one new line. That's pretty fucking sick. That's pretty sick. Yeah, that feels good. That feels good. Okay. So I guess the other thing that we have to do here is now we have to make sure that we handle scroll back. I think that's the last piece here that's like kind of sketchy. is like what happens when we hit the end of the buffer. Okay. Okay. Maybe let's add source main and git commit -m proof of concept terminal buffer storage. Okay. Because I worry that we're gonna fuck something up here. Could also maybe do a circular buffer to avoid reallocations. Yeah, maybe we do that first, huh? I was thinking that. So maybe we start with circular buffers, and then when we evict the circular buffer, we push that line into the scroll back. I like that. So here our terminal buffer, he's going to have like first line index and last line index. And these are going to be initialized with 0. At beginning and end. Right, because we're basically trying to say that we're going to have like our buffer is like some thing here, and he's going to have start. The first line is here, and the last line is here. Or let's say that the last line is here, right? Then we go like bum 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 bum. We insert some data, right? And then we go like, oh shit, we have more data to insert. And so then we like move the start down and like the end up. And then when we like serialize, we kind of iterate, like we start here, 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 and then we go here. And that like makes sure that we don't have to like all of the data that's like already there, we don't have to like touch it. It like works okay. Fuck, this is like a bad explanation of circular buffers. Let's try again. Let's like remove the line concept for now. Just imagine, you have a buffer that's like fixed size. He has like 4 elements in here. And you want to say 1, 2, 3, 4. You have this data in it, right? And so you're like, I want to push a 5th thing now. So I want it to be so that like when I push the first thing, I want to see like the last 4 elements that I pushed essentially. So if he's trying to push a 5 here, the last 4 elements would be like 2, 3, 4, 5, right? Because he's trying to push like the 5th thing. And so a way, like you can look at these 2 things. You go like, well, what's the difference between these 2 things? Well, the 1 goes away and the 5 comes back. So you can just like write the 5 where the 1 is. And then like the only extra tracking you have to do is track that the start and end of the buffer are like not the start and end of like the physical array. And then I think that I always have to think about like this edge case. I think that you want to store, right? If the thing is, you have like 2 pointers or 2 indexes in the buffer that you're keeping track of the start and end, and I'm pretty sure you either need, to say that you need like a sentinel value to say that the buffer is full or empty. One of the 2, I think. Let's think about this. So if it's empty, your start and end. Your start is at the beginning, and your end is also at the beginning. And then if you fill up, so at this point, you go here. Start equals end is empty. No need for sentinel. Hear me out. Or I've been implementing circular buffers long this whole time. So in this case, say we have 2, 3, and 4 here. You have start at the first element, and end is 1 past the last element, right? So then you say, okay, well, then we had a 5 here. Now this guy points 1 past the end of the buffer, which is like normal iterator things, right? But then what happens, like, say you're like inserting from this point, you have like 1, this guy goes here, then you put 2, he wraps around to here. Then you put in 3. He wraps around, he goes here. And then 4. And then if this guy would have to like equal the start point again, if the buffer is full, which like isn't allowed because that's the same thing as empty. Right? Empty is also start equals end. So I think that if it's full, I just set it 1 outside. I think. I'm pretty sure that's how I usually do this. I'm not sure if that's like the most efficient way. That mean over capacity, I think that's a different case. But like, how do you like? What if you're at capacity? At capacity and empty have to be flagged differently. So I think that like if you have start and end, start equals end is empty. Then start equals end can't be full as well. You know what I mean? And if you have it so that the end pointer is like the element, if you instead of doing 1 past, you do at the same point, then you can't signify empty. So I think there you do need this. So we do start equals end. So we'll say that our convention here is 1 wrapping index past the end. Convention. Well, I don't know. We'll see. We'll see. Okay. Or you could just allow n-1 items, and then I'll allow start equals end unless empty. Yeah, but I think like why bother? Why do that though? You know? I think that like you can just, that's effectively what I'm doing, except I'm just not allocating the nth minus 1th. Like, I think. Maybe not. We'll see. Okay. Is there a way to abstract the circular bufferness of this thing so that it's easier to think about? You could do something like struct circular lines or something. I like this because I don't want to have to like pack all of, like this is already complicated. I would like to like abstract the concept of start and end. But I guess if we have to construct lines like on the fly, so we have to store these things here and we'll pass them into the circular lines thing after. So we'll say start is usize, a mutable reference to usize. The end is a mutable reference to usize. And the elms is a slice of lines. Like this. Oh, I think. Is that legal? Can I construct that? Let's just see if that's like compiles. So if I say like in this guy, hold on. If I say like test function takes immutable self, and I say let lms equal to self as lms. Finally caught a stream live, love the vids. Hey, thanks, appreciate it. If you had like lms, so we need to get all of the lines out of here. So let lines equal to I guess it's like mute lines equal to vec new, and then we push each line in here. So we say like lines push for I in 0 to the height, which we need to cache. You would then get the line. So you say this thing here. Fix me factor out, which means that we need the width as well. And so this is y here. And then for each of these, we just push line. Lines push line. And you could even do with capacity here. Because we know how many. So the capacity is height. Yep. But we cannot borrow this as mutable more than one at a time. Fuck me. Okay. So you actually have to do something crazier. We gotta get crazy with it. Okay. This guy, we make him mutable, and we consume a chunk of the element each time. So we say, elms data. Is there a reason to why we abstract the buffer into a circular buffer of lines? Wasn't it good enough to have one contiguous buffer? Because here, let's open up this guy, right? When I press enter here and I say echo test, this guy gets like pushed up, right? And the stuff that used to be at the top of the screen is now no longer in the buffer. So kind of like as we scroll, each line, like all of the lines that are currently on screen, right? Echo test, they stay on the screen until they get pushed into the scroll back. So I think that like what makes sense here is to use a circular buffer to represent the like, current visual area. When I press enter here, he pushes a new thing into the circular buffer and pops the last thing out, and that last thing will get like pushed in the scroll back. Maybe use a vectq, but you want the buffer to be the same size. Yeah, I think the vectq won't work, but I briefly thought about it. But I think it wouldn't work. I think. Okay, so what we can do though is we can like split the data. So we can say elms data split at mute width. Yes. Wait. This will work. Okay, so we say let this data and remaining data is equal to this. Maybe we say let mute data is elms data. Hold on. We're getting somewhere. We're getting crazy with it. So this data and remaining data is data split at mute. Then we say this data goes here. And data is equal to remaining data. Hell yeah. Okay, then we do the same thing for the other ones. So let mute lengths is equal to elms lengths. And let mute new lines equal to elms new lines. Hell yeah. Okay. And then we do this lengths remaining lengths. This new lines and remaining new lines, and this is going to be lengths split at mute 1 and new lines split at mute 1. Hell yeah. And then lengths equal remaining lengths, new lines equals remaining new lines. Yep. This lengths and this new lines. He doesn't like that? Oh, because I spelled lengths wrong, maybe? Somewhere? Lengths. Nice. And I got these wrong? This takes len new line. Oh, I have to specify the first element here. Hell yeah. Hell yeah. I think that's gonna work. Okay, so now we have the lines, and we can say circular lines start is the first line index uh, end is last line index, and the lines is the lines. Okay. Elms, maybe, is what we called it. And this guy, we're going to make him a vector here, I think. In which case... Oh, yeah, that's probably fine. That's probably fine. I'm not really sure if we, like, need this vector like this. I think we do. I think we do. And this guy is going to return a circular lines. Double borrow. So as elms is going to need first line IDX as like this, and last line IDX, which is annoying, but you know, it is what it is. So first line IDX is self first line IDX, and last line IDX is self last line IDX. Or we could not do this like as elms by taking in self by mutable reference, but by taking in each of the individual pieces individually. But this feels easier to me. Which means that here we can do start is elms dot this. And we're chilling. It looks like that compiles. Okay, so now we can like construct these circular lines. Circular lines. We'll make a function like that. And then when we insert data, what do we want to do here? So this loop now is going to, instead of y plus equals 1, we're going to do something with the circular lines here. And what is the thing we're going to do? I guess we are going to push a line. Pushing doesn't really make sense. We might be overwriting. Get line. And we're going to take in mutable self. And we're going to get the line IDX. And what's he going to return? Like a line? Maybe? And then he's going to say, like, he has self elms y? Something about this doesn't feel right. I think we don't. I think there's a way to get this vector up there, by the way. I'm just noting that for later. So I guess, like, what is the API? We have data that's written. So if they're trying to get a line where y is within the existing bounds, then we can just write to the line. There's no, like, circularness happening. So when does the circularness happen? The circularness happens when they push a line. Okay. That makes sense. And this is going to be related to something. When do they push lines? It's going to be like, as we insert data, if y is greater than the index of height, we push a line at the scroll back. Hold on. My dog's chewing on something. I just want to make sure it's like not dangerous. One sec. Where'd you get this? That's a nail. Where did you find this? That's not good. Oh no. That's good. Come here. No, come here. Up. Girl. Okay. That's not good. She ripped the like she found that the what's it called, like when your floors are like very slightly different heights, there's like a little ramp that goes from like one floor to the next floor. Uh Apparently it wasn't like connected that well and she ripped it off. Like she thought it was a chew toy. That's not good, but we'll deal with that later. Okay. So if y is greater than height, then we push a line. Which means that here, we kind of need like... We need like... We need to have the circular buffer. Okay. Which means this... There's going to be some like mutability problems here. Let's think about them. Circular lines. Well, maybe not. Can we work with the lines as is? Like, is this good? Okay, so this get line. Let's do this for now. First mutable borrow, second mutable borrow, but can we like do we need this elms? Because here we can say each of these is gonna be like lines get line unimplemented. And we're gonna say let line is equal to lines get line y. Like this. If y is greater than equal to height, else this is gonna be like lines push line, otherwise get line. Something like this. And push line is also gonna return a mutable reference to a line. Cannot borrow as mutable, so this is mutable. Okay, so I think that works. And so here we can say if... So we're gonna have to like do the wrapping logic. So we're gonna say self start plus y mod the number of elements. And we just return that. Unless the capacity here is lower. So here our length is going to be something like self, okay. Let last idx is equal to last line idx self n, sorry, I'm in the wrong area. No, it's if the end is greater than or equal to self start, we return self end minus self start. Yep. Otherwise, we return self end plus elms len minus self start. Okay. So now, if idx end minus start plus 1, that doesn't work though, right? Because if end is smaller than start, then it'll be an overflow. Because it's not it's like not, they're u sizes, not I sizes. I mean, I could use I sizes, but I think that, end minus start plus 1. No, because end is 1 passed. We're storing end as 1 pass, but that does mean that we need to say if self.end is equal to the length of the elements as our sentinel value, we return len. There we go. Right, because we're saying that if they're the same, then it's 0, which I think that's the convention I wanted to use. Okay, so index is the start plus y, percent the lengths, and we can say if idx is greater than or equal to self length, we panic. Invalid for now. Otherwise, return the line. Okay. Lifetime may not live long enough. Because maybe we need to flag this like this. Hey, just joined. Are you working on Alacrity? No. Well, we're working in Alacrity on something else. Because our terminal emulator Termi is too shit to actually use right now. But eventually he will be usable. But for now, we have to live where we live. Okay. And so push line, what's he going to do? He's going to say if self end is equal to self elms len, and maybe we'll even hide that behind a is full, because I think that will just make my life easier in general. And we'll just say this. Boom. So here we said if self is full. Womp, womp, womp. So here we say if we're full, we do something. And if we're not full, we're going to do something else. Yeah, and what are we going to do in each case? Something. I don't know what, though. So if it's full, we're going to increment start. So this is going to be self.start plus 1 mod elms.length. I don't know the order of operations, so I'm just going to slam a bracket in there. Okay. And then we have to clear the previous one. So we'll say like let line that we're returning is equal to self elms at self start as a mutable thing. Then we turn the line. And we have to reset the line. So line.len is equal to 0. Is the implementation of is full correct and cannot be equal to self element's length in the case of circularness? Okay. Clarifying again. We have 1, 2, 3, 4 elements, right? Say that in an empty case, we have start. This is start is equal to 0, end is equal to 0. In the case where we have 1, 2, and 3, and empty, start is equal to 0, end is equal to 0, 1, 2, 3, right? He's pointing here. In the case of it being full, we have 1, 2, 3, 4. Start is 0, end is 4. And the case where we have 4, 1, 2, 3, start is now 1, end is still 4. We're using end is equal to the length to signify that the buffer is full in any case. Because we talked about a little earlier how you have to either have a sentinel value for empty or full. I think. I could be wrong, but I'm pretty sure that that's correct. I think. I shouldn't say pretty sure. This line, let's give him a clear method. So that I don't have to break abstraction here. Self len is equal to 0. And I guess we probably should clear the new line here too, hey? If he's like a new thing. Probably. So here we can say line clear. And then we return the line. Otherwise, we say self.end plus is equal to a wrapping add of self end plus 1 over self elms len. Yep. And then we return line self end. This. Nope. Self elms self end like this. And I guess in this case we also want to clear the line. Yeah, maybe like this. I think. Not really sure. Cannot borrow self elms as immutable. Oh, sure. So we say let len is equal elms len is equal to self elms.len because Rust needs the help to understand that things are cached. Because it doesn't know that the length field of this guy is free. And this guy needs to also be a line of A. Cool. So I kind of feel like this might all just kind of work now. I'm curious. So let's first cargo run the existing thing. Invalid. Fuck. At 56. GG. If IDX is greater than or equal to self.length. Okay. Right, because this is actually more like... Hold on. If line is... This is more if y is greater than or equal to lines line here. Then I think that's fine, because then it will push in the case that we need to. Okay, so that's something. We got hello world here. But it's at the beginning of the buffer, which is a problem. So this isn't quite right. The like indexing code here is doing the wrong thing. Okay. Oh, this needs to be while y is greater than lines len. Lines push line, I think. Because we need to handle the case where they're writing to something we haven't checked. And then when we loop, I think that'll do it. Okay, there we go. So hello world is at like line 5, 6, 7, 8, 9, which is great. Right, because we wrote it 7, 10. And so what happens now if we write like line 9, 10? Hold on. Okay. Gotta bounce. Thanks for the stream. Follow to stay in touch. Thanks. Appreciate it. Enjoy. Okay. So here what we're hoping is that if we insert a long enough string, the quick brown fox jumped over the lazy dog. We're kind of hoping that we're going to get to the end of this and that the hello is going to get like pushed up as the text comes in. So we see hello world, the quick brown fox jumped over the lazy dog. Okay, so wait, that's a really good sign at first. So we see that the thing is wrapping, and if we keep writing, we should see that like the hello world eventually gets overwritten as well. And then the fox said hello. I don't know. And then the fox said hello. ASDF 124 XYZW. Hello. Yeah, so we are seeing that like lines are getting evicted. I think maybe one too many are getting evicted. Because we're seeing an empty line when I don't really expect to. Yeah, like this line is getting evicted, so there's a problem there. Where is that coming from? Why is this just sitting here? I think this if statement was garbage. Oh, yeah, this is a mistake. This should be self new line is equal to true. Let's go away. Yeah, okay. But that's unrelated to the problem. This problem is... I actually don't know. I'm a little bit lost. So when we insert data, while y is greater than lines length, we do that. But I think we're not hitting. Oh, we are hitting. Then we iterate and we push a line. It's because we are iterating one more time. We were pushing the line before we checked if we had any data. So we should break if data is empty. Then if we have data pushed, then we get the line. There we go. That fixes it. And now the circular buffer is working, but we need to make sure that when we serialize, that we're serializing in the right order. So here, we actually want to go let lines is equal self circular lines. And for y in 0 to lines length, we want to push this thing. So it's actually let line is equal to lines get line y. Cannot borrow lines as mutable, so we just slap a mutable on here. Delete these guys. And fuck. Not quite. What have we done wrong here? Print line. Lines length is lines len. We see that as 1, which is clearly incorrect. So let's start with hello. So we see one line there. World. Now we see 2 lines. Great. Do it again. Hello world, hello world. And let's then maybe even a few more times. Okay, so it's when they wrap all the way around, there's a bug there. So lines len. I don't see you debug exclamation mark often is super useful. I don't know if I know what that does. I'm assuming that's a Rust macro. Prints and returns the value of a given expression for quick and dirty debugging. Oh, that is useful. I didn't know that existed. Will I ever use it? Maybe. Maybe I'll forget about it in like 3 seconds, but it does seem like it could be useful. Okay. So, line. So if end is greater, we're probably in this case, I think, where end is less than start. Or end is, if element is full, if we're full, then this is equal to that. maybe I'll print line full. Here I'll print A, and here I'll print B. I just want to like see which case we're in. Case A. Maybe we print end is this, start is this, and we print self end and self start. And 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Ah, we're not incrementing start when we loop. I see, I see. So here, we just need to do the same thing for start. Nope. Maybe not. No, wait, that should be right, because if it's full, we increment start. Otherwise, start stays, because it's not full, and end increments. So why is that not happening? So here... Oh, end is getting to 0 instead... Ah, I see. It's this guy. We don't actually have to modulo this. Because when he fills, he will... Yeah. When he fills up, he'll hit the length, and then we'll just never hit this path again. Yeah. That's looking better, I think. Except now, end is getting fixed at 10, and start is also not moving. Hold on. Oh no, that's changing. Okay, yeah. So start is going 1, 2, 3. And so as I keep pushing ASDFs here, if I type this a few more times, we should see hello world get pushed into like line 0 and line 1. Okay. So now he get pushed into line 1. If we type it a couple more times, he'll get to line 0. Hello's in line 0. Nice. And then he's pushed all the way off the edge. That's pretty sick. Okay, so that's working. And so I guess now the piece that we're missing is we need to push that line that comes out into the scroll back. So when we push a line into our circular lines, he should return struct circular lines push response. And he is going to return both the removed elem is going to be an option. We might remove something, right? Or active elem, or yeah, the one we want, which is always going to be valid. And so this guy's going to return. Maybe these guys need to be meal references. I'm not sure. Okay. And this is going to be a circular lines push response with inferred lifetime, I guess. And here, if it's full, we're going to return the evicted line. Oh, but that's kind of odd. Because we're reusing the same memory. So maybe we don't do this. And instead, we say, we get the last line. And I guess theoretically, this might be empty. But we'll just assume for now that it has to be valid. So if self end is equal to self start, we'll just panic for now. Last line invalid. Just for now. And then otherwise, we will just return the correct line. Self get line self len, maybe? -1? If self len is equal to 0. Otherwise this. I think that's right. Seems fine to me, probably. I think so. I think so. So now let's just go into the buffer stuff. And I guess here is where we evict, and we can say, ooh, if lines len is greater than or equal to lines capacity, okay, which means that this guy needs a capacity thing, which is just capacity self is the same as the number of elements. Okay, so if we are greater than or equal to the capacity, then we will say print line, evicting line, and we'll write out what we're evicting. So it's lines, line, serialize. Yeah. And I spelled serialize. Wow, dude, that Z was so far from where it's supposed to be. What the hell? Okay. So now if I run this, we should see. Let's get rid of these other prints that are fucking annoying. Get these out of the way. This one out of the way. Where's the other one? This. Evicting line, this. Okay, well, let's slow it down again. So, hello world. And we're gonna write this. I wonder if we can do something like 1, 2, 3, 4. Yeah, whatever. Hello world. Hello world. Is that how much text is that? It's like a little more. Hello world ASDF. Hello world ASDF. Okay. We got a little too much. I want to see like the first eviction to make sure. So why is there anything being evicted here? Shouldn't there be nothing being evicted? Yeah, something about this doesn't feel right. Right, in this case, why does it ever think that something's being evicted? Evicting, why is that, did I spell it wrong? Evicting line. So if line's length is greater than or equal to the line's capacity. Oh, I guess we should say if lines is full. Although we should come back and see if that's broken in some way. He does still think that he's evicting lines, but he's clearly not. Oh, but he is evicting lines. They're just empty lines? That sounds right. Right, because, hold on. Okay. Say we start at line 10 here. Or 9, I should say. This puts hello at the bottom. And if I type more here, he should evict here. But he's saying that he's evicting line hello. So he's just confused about which line. The last line thing is wrong. This is wrong. So we should be saying get line. Self.end maybe? Yeah. Something to do with self.end. If we're full, it's self start -1. Yeah. No. Oh, it's because it's not the last line. It's the first line. The line that we're evicting is the first line. Yes, 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 yes. Because the last line is going to stay there as long as possible. Whoops, slight mistakeys. Okay, okay, okay. So now let's go back into this, like, just write this a few times. Okay. And yeah. So as we go, we're like evicting line, empty lines, empty lines, empty lines, empty lines, and then we have stuff in here. Nice. Which means now we can add a scroll back. Hell yeah, hell yeah, hell yeah, hell yeah, hell yeah. So here we can have like scroll back is just a string for now. Oh dude, this is so sick. I feel like it's all coming into place. Like none of these functions are like crazy complex, but we've got like the complex behavior we need, and it's feeling so good. It's feeling so good. Okay. So self scroll back plus equals this. And if there was a new line, we push that as well. So if let line to evict is equal to this, self scrollback plus equals line to evict serialize. And I guess maybe our serialize thing here. Well, yeah, we'll see. We'll see. We'll say if line to evict new line, self scroll back plus equals this. Like this. Okay. So we need to scroll back here. String. Which should be string new. Oops. Self scroll back. Cannot borrow self scroll back. Because fuck me, man. Fuck. It's because we have this like borrow here, which is a pain in the ass. Okay, you know what? We're going to take this as Elm's shit. And he's not going to take self by reference. Instead, he's going to be one of these guys that takes in data. Yep. And this is just me mute U8. And so we're going to call this buff, I guess. And self buff turns into buff. And then we need to take in the length offset as U size and the new line offset as U size. What a pain in my ass. And the height. And then he's not going to return these. And as LMs, now I need to see like and mute self buff and self length offset self new line offset self height. Yep. This guy's got to go here, here, and here, which is annoying. Use associated function syntax, so it's self like this. Okay, and this guy is not in here anymore. And as LMs, now we're just gonna yoinkies this everywhere. And I think that's it. Nice. And now we have to give the same treatment to the circular lines thing. So these need to be and mute like this. Which means that first, these guys have to come in like first line IDX and last line IDX. And this guy can't be and mute self. He's got to take in like the same shit as this guy did. As well as first line IDX and last line IDX. Yup, which means that people who called him need to pass in all of this shit. Circular lines. It's gonna be like paste this and then self first line IDX and self last line. This is why working in Rust is fucking annoying sometimes. This type of shit is like just, it's awful, but it's the only way that the borrow checker can like know what the fuck he's supposed to do. But fuck is it annoying. Oh, he also fucking needs the width. Gross. So this guy needs width like this. And then this guy needs this. But now we can use self.scrollback. Isn't that great? Fuck that. So it's just like now, like, because of like the mutability shit, even though it could figure out which portions it uses, like, I guess it's not part of like the I don't know what it's called. It's not part of the, it's part of the API, so I guess it kind of makes sense, but man. Like it can't like infer which elements are being used when you like bind with self like that. So it's just annoying. Okay. So now we can say, let's look at the scrollback. Scrollback. Okay, so now we have like the first little bit of hello ASDF, hello, right? And now as we push more things in here, I think we should see this string like continue on. So here, if I just keep going, we now see hello ASDF, and now we can get kind of crazy in here, and we can insert a new line in the middle of hello ASDF here, and we see in our scrollback we have hello as new line df hello's df. Hell yeah, baby! That's so sick. That's super sick. That's super sick. We made so much fucking progress today. We fucking cooked. What did we do? We did so much. So we constructed this buffer that is actually like, I don't know what the right word for this is. I want to say like polymorphic type, but I think that's not, I think that means something else. But this terminal buffer has like one allocation where he stores like several slices of different types of data contiguously in memory. We built this like line abstraction that allows us to insert data into a line. And basically he says like, how much data can I get? And I will like expand until that, I will expand until I run out of room. And then I'll tell you how much data I copied in, overwriting where you asked me to. Then we added this like in the terminal buffer, we added this like circular buffer type, which works on the set of lines where we will retrieve whichever line is the most relevant. If the buffer is full, we like push that line into scrollback. Otherwise, we work with that line, and then we push the data into the line. It's so clean. It all like works so simply. The only thing I don't like is like this shit show. But well, we can go back to that. And I also don't like how I'm not convinced that this has to be a vector here. I'm not convinced. I think we could like maybe construct these directly out of the U8, but to avoid the one allocation. Not that it fucking matters, but I think we could. But yeah, pretty happy with that amount of progress. That's super sick. I didn't update this to do it all, but I guess it's kind of like there wasn't really a very clear lines as we were going. But yeah, super happy with that. Super happy with that. Yeah, look at this. Look at this. Look at that. We have buffer this guy coming in. He's got the scroll back. The scroll back is preserving new lines. And so like what's going to be nice about that is when we like resize the window, the scroll back will automatically resize as we need to. It's just all looking good, man. It's all looking good. Yeah. So thanks for watching. If you like what you saw, we stream most days at around 1 or 2 o'clock Pacific time for like 1 or 2 hours. Today was a little long because I was, when you get in the mode, it's hard to stop. But yeah, we're working on this terminal emulator. I think we'll probably keep going on this for a while until it's usable at the very least. Because I think I'm like motivated enough to keep working on this to the point where I want to be able to use it to do my development. But barring that, we've been covering like some other stuff as well, some like web dev, some operating system stuff, some like AI, some 3D. Just whatever we feel like working on. That's what we work on. If you want to check out past projects or get catch VODs when you're not available, there's a YouTube link in the Twitch description where all VODs go up reasonably soon after, usually same day. There's a GitHub link as well where code eventually ends up. I think this code won't end up exactly as it is on GitHub, but once we integrate it with the rest of the terminal emulator, I think it will end up there. What else? What else? If you're watching on YouTube, you should swing by on Twitch. There's a link in the YouTube description. And otherwise, I think that's it. Thanks, guys. Catch you on the next one. Bye!